I want you to know when it's out there. I was late this week because we had a break, right? So I took a break. I put it out there the following week, and some of you looked at it before. So, all right. So let's go to 25, lesson 25, and this is a solution of equations. This is stuff that should be reviewed, and it's just the basic steps for solving equations, right? And so there are two basic algebra rules that they have at the beginning of this lesson when you're manipulating equations. Does anybody know what those two basic rules are that you always need to remember? Yes?
Whatever you do to one side, do to the other.
Yeah, and so that sums up both rules, right? And so in this case, it's if you add or subtract something from one side, add or subtract it from the other side, right? And then if you multiply or divide from one side, make sure you do that to the other side of the equation. So that's the basic rule. Make sure whatever you do it to both sides of the equations. We'll learn some Twix. We'll learn some, that's a candy bar. I wonder if that's based on somebody not being able to pronounce the word tricks. I've never thought about that. Where does Twix come from? You know, maybe they had a kid that couldn't pronounce their R's and just like, they do Twix. I don't know. You know, Elmer Fudd was their child, maybe. I don't know. So just food for thought. So we do it to one side, we do it to the other side. Like I said, when you do some more advanced math stuff, you're going to find out that sometimes that's still basically the rule, but we may think about it as doing both things on one side. So like, for example, do you guys agree that if I have this 17 here, if I add a 2 to this side, as long as I immediately subtract out the 2 from that side, I haven't really changed the value of that equation? Because 2 minus 2 is 0, right? So that's kind of like a trick that you'll use later on when you're doing something like completing the square. That's way down the road. But really what I just did was really the same thing. I added a 2 to both sides, but then I subtracted it out from the other side. So what do we want to do to solve this equation here? What's our first step? We're trying to, when I say solve it, I'm talking about solving for x, right? So when I say solve for x, what do I mean by that?
Get it by itself.
Get x by itself all on one side, right? Everything else is on the other side. X is by itself on one side. So my first step is going to be what? What's connected to this x here that I've got to move?
4.
Not the 4. I can't start with what it's multiplied by. I have to start with what it's added or subtracted from, okay, or 2. And so I have to start with the 5. That's the rule. So I want to subtract out the 5. So I'm going to do that on both sides, all right? Now some of you learned to do it that way, and which is great. That's fine. And so I'm just going to say 4x equals 17 minus 5, right? Or I can just go ahead and do the math with the 17 minus 5 and say, I know that 17 minus 5 is 12, so I'm going to write my equation that way, all right? Some of you instead learned to think of it like this: 4x plus 5 equals 17. And so I'm going to subtract the 5 from both sides, which always means that I'm going to remove it from that side. So I'm just going to rewrite this as 4x equals 17 minus 5. I'm going to write it like that, right? And say that that's 4x equals 12. So however you used to think about it is fine, as long as you recognize what you're doing is you're really subtracting a 5 from both sides, and that's why you're allowed to do it algebraically. Did something confuse you with that, Alexa?
I thought you were supposed to subtract 4 from each side to get x alone.
No, because right now, remember, my goal is to get the x on one side all by itself, right? But right now, this 5 is also on the same side that the x is on. So before I get rid of the 4 is not added to the x. The 4 is what? What's this relationship to x? It's multiplied by the x. So before I can deal with multiplication and division, especially multiplication, before I can deal with that, I need to deal with any terms that it's added to or that's subtracted from it. Okay, so I get rid of those terms first. So I move this 5 over by subtracting a 5 from both sides. Does that make sense? Do you see? You understand how I got what I got? 4x equals 12. Now I can get rid of the 4. How do I get rid of the 4? If it's multiplied times 4, then what's the reverse of multiplication? Division. So I'm going to divide it by 4. So I divide this side by 4 to get rid of this 4. That'll cause those 4s to cancel out. But whatever I do to one side, I have to do to the other side in algebra. That's the rule. And so that's going to leave me with x equals 12 divided by 4 is 3. So that would be my final answer. Okay? So So when it's in this form here, we're going to start with addition or subtraction, and then we're going to move to multiplication or division, okay? Let's try one that's got some crazier signs in it, just to make sure that we can work with negatives. When it's, there's just kind of more room for error when you've got the negative signs in there, but if you'll take your time, write out each of the steps, you won't get confused with the signs, and it'll work out fine. So negative 7k minus 4 equals negative 21, all right? I want to get the k by itself, right? And this one here I'm solving for k. First step is going to be what? What have I got to get rid of that's on the same side as the k first? The negative 4, right? Does everybody see that? And since it's a negative 4, this time I'm not subtracting from both sides, I'm adding to both sides. I'm going to add a 4 to both sides, because that's how I'm going to get rid of this 4 over here, right? So I do a plus 4 and a plus 4. Negative 4 plus 4 is 0, so that one goes away. So on this side of the equation, I just have negative 7k. And on this side of the equation, I have negative 21 plus 4, which is going to be what?
0.
Huh? Negative 21 plus 4?
17.
Positive or negative?
Negative.
Negative, right? 21 is bigger, so it's going to be a negative 17. That step makes sense to everybody? Is it clear how we decide whether we're adding or subtracting? Okay. So now what have I got to do to get the k all by itself?
Add 7.
Not add 7, because that 7 is not added or subtracted to the k, it's multiplied by it. So
Divide.
I'm going to divide it, right? And I got to divide by the negative 7, because I want to get rid of the negative as well, because I just want k. No sign on k, just k all by itself. So this is going to make those cancel out, right? And so I'm left with k. And on this side, 7 won't go into 17, right? So I'm just going to leave that as 17/7, but I'm going to drop the sign. Why am I dropping the signs? Yep.
Because there's two negatives that
Yeah.
cancel each other out.
A negative divided by a negative is a negative. I mean, it's a positive, right? Just like a negative times a negative is a positive. So we're left with a positive answer, so that would be our answer for k in this one. If I asked you for a decimal, you could plug it into a calculator and get a decimal value of that. But we'll typically just leave them like fractions in problems like this. All right? Does that make sense to everybody? Speaking of fractions, let's throw a nasty fraction in there. See what happens. See if we can handle that. I can see Hannah's already scared. As you should be. All right, so let's try this. 1/5 ilm minus 1/2 equals 3/4. Wow, this thing has fractions in it. What am I going to do? Guys, what are fractions? They're just numbers, like all the other numbers are, right? Don't let the fractions throw you off. They're just numbers. It's a little wackier adding and subtracting them, sometimes. But at the end of the day, they're just numbers, and so they work just like all of these problems did. I'm trying to solve for ilm, so what's going to be my first step?
Would you subtract 1/2 from 1/2?
I'm not subtracting because it's already negative. I'm adding 1/2. Do you see that? So I'm going to take this and I'm going to add a 1/2 to both sides. Okay. Now for this particular time, instead of doing the addition in our head, I'm going to actually write this out. So on this side we have 1/5 ilm, right? These cancel out. And so on this side, on the other side, we have 3/4 plus 1/2. I'm going to write it out like that so we can make sure that we're clear on how we combine those together. But does everybody see how I got there? Does that make sense to everybody? Now, how do I add those fractions? What's the rule? We got to get a common denominator, right? What's the common denominator of these two guys going to be? 4. So this one's already got a 4, so we just leave it like it is. What's this 1/2 going to turn into if we get a common denominator of 4? 2/4. We multiply top and bottom by 2, right? So 2/4. Now we can combine them together. When we combine fractions with a common denominator, when we're adding fractions together with a common denominator, what are we actually adding? Just the numerator, right? So 3 plus 2 is 5. We don't touch the denominator when we're adding and subtracting fractions. After we find that common denominator, we don't mess with that. We only add or subtract the numerator. All right? Final step. What am I going to do? I got to get the m by itself. What am I going to do to get rid of that 1/5? Divide it. That's what we did over here, right? We divided by 4 here to get rid of the 4. We divided by -7 here to get rid of this -7. Same thing here. We're going to divide by 1/5 to get rid of the m. But this is what we have to remember. So this is what we're doing. 1/5 m divided by 1/5. Well, that looks really complicated, right? I'm dividing by a fraction. How do I divide by a fraction?
You flip it and then multiply.
What's that called? The reciprocal. That hint is really important for the test that I just gave you guys, that you remember what a reciprocal is, okay? So the reciprocal is just you flip it, right? So, and you multiply by the reciprocal. When you divide by a fraction, that's the same as multiplying by the reciprocal of that fraction. So this right here is equal to 1/5 m times the reciprocal of 1/5, which is 5/1, right? Now, what is this answer going to be? I can't do anything with the m, but I can multiply 1/5 and 5/1. What do you get when you multiply 1/5 and 5/1? You just get 1, right? You can think of it as these 5s canceling out, and you're just left with 1. You can think of it as you get 5/5, right? Which equals 1. Whatever's easiest for you to think about it. Just realize that when it's the same fraction and you're multiplying it by its reciprocal, it's always going to be 1. Yes? Yeah. All right, so we multiply by the reciprocal here, and when we do that, I'm going to put brackets around it just so it's going to be a little easier to see. I'm going to multiply both sides by 5/1, right? I'm dividing by 1/5, which means I'm multiplying by the reciprocal. Is everybody cool with me doing that step? Make sense? And so when I multiply by the reciprocal on this side, I'm just left with 1 m, and we always, the 1 is understood. We leave the 1 off. What do I have on the right side? Now, when we added fractions, we left the denominator alone. We found a common denominator, and then we only added or subtracted the top. But when you're multiplying fractions, you have to multiply the numerators, and you have to multiply the denominators, right? So 5 times 5 is 25, and then 4 times 1 is 4. Any questions about that?
Would you leave it as an improper fraction, or would you?
I would. I mean, it's possible. You know, you guys know I like to give you multiple choice so you can see the answers. And so if it was in improper, if it was in mixed number form on the answer, then yeah, you'd have to convert this to mixed number. But normally, I would just leave it like that. I wouldn't convert it. Okay. All right, so let's go on to the next chapter, which is basically doing more complicated equations. The same thing, but just more complicated varieties. And it's still not really any harder. It's just that in these equations, you're going to have variables on two sides. Okay. By the way, there's one last problem that I didn't do in chapter 25, and it was just the same type of problem, but it has decimals in it instead of whole numbers or fractions. A decimal is just a number, right? And so you're just going to do the same thing. You're going to add or subtract to get the variable on one side by itself. You're going to either add or subtract the decimal, and then you're going to divide by a decimal. You guys have calculators, so that's easy to do, to just use decimals. That's actually probably easier than dealing with the fractions here. All right, so let's do something more complicated, and something like this. 3x minus 4 equals 5x plus 7. This is no harder than what we did. The only difference here is that we've got x's on both sides, so we're going to have to decide which side we want to put our x's on, right? Because the goal is, if I'm solving for x, the goal is to get x by itself on one side, right? All the x's have to be moved over to one side, and it's got to end up being just a single x. So we just have to decide which side do we want the x on. Do you want to put the x on the left or the right? Doesn't matter. The answer is going to be the same when you're all said and done, but who has a preference? You care? I'm going to put the x on the right side. Does anybody know why I'm going to put the x on the right side?
Because of the 4 being on the right. And you want to subtract from it.
The 4?
Yeah.
It's not the 4 that I'm thinking about. It's actually the 3x and the 5x that I'm thinking about. Because if I put the x on the right side, I'm going to end up with an x term that has a positive coefficient. That's the only reason I'm doing that. It doesn't matter. It's not that big a deal. I just would rather work with positive numbers than negative numbers because there's less chance that I'm going to mess up a sign. And so I'll show you what I'm talking about as we're moving along. All right. But I'm going to begin by saying I want to move my x over here. All right. So I've got a positive x over here. If I want to move it to this side, I've got to subtract it from this side. Right. Whatever I do to one side, algebra says what? I have to do it to the other side, right? So I'm going to make this a negative. I'm going to do a negative 3x here. Why did I put this below the 5x?
Because they're the same variable.
They're the same variable, so we call those like terms, right? So these cancel out. I'm left with a negative 4 here. What's 5x minus 3x?
2.
2x, right? Plus 7. You see why now I decided to move the x over there? If I moved the x over here, I'd have had 3 minus 5x, and I'd have had negative 2x. I can still do that, right? It's just I'd rather have a positive coefficient on my x, all right? Now what am I going to do? Now I've got the same type of problem that I had before, right? I'm trying to get the x by itself, so what do I have to get rid of now?
The 7?
The positive 7, right? And so how do I get rid of a positive 7? I subtract the 7, right? So I'm going to subtract the 7 from both sides. So over here, they cancel out. I'm just left with 2x on this side. What do I have on this side? Negative 4 minus 7 is?
Negative 11.
Negative 11, right? And so our final step, that's been our final step in every one of these problems, is we're going to divide by the number that's in front of the x, right? So I'm going to divide by the 2 to get rid of it. Same thing on this side, so these 2's cancel out. And so this is the point at which I'm going to flip my, my equation around and put the x on the right side. And on this side, put the x on the left side. And on this side, I'm going to say negative 11 halves. Because negative 11 divided by 2, we can't simplify that any further. So we just leave it as negative 11 halves. One thing I did do though is I brought my negative out to the front, right? It was just on the 11 here, I just brought it to the front of the entire fraction. And that would be my final answer. And because I'm a good algebra student, I'm going to put a square or a circle around my answer. If you guys would do that, that would help me out. All right, any questions about that? Let's jump to the end and do a really hard one, all right? Let's see. We scared Hannah when we did fractions. Let's see, who can we scare with this really hard one this time? We're going to do, let me write this down. 2x minus 5 plus 7x equals 5 plus 3x plus 10. I can see the fear in your eyes, Liam. All right, it's got a lot more terms, but at the end of the day, this is no harder than what we've already done, right? The only difference this time is before we start moving things to one side of the equation or the other, what are we going to do first?
Add the 7 and 2.
Add the 7, add the what? The 7 and the 2, okay? We're combining like terms. So we look on the left side and we say, do we have any like terms on the left side? Yes, we do. 2x and 7x are like terms, so we're going to add that. 2 plus 7 is 9, so this is going to be 9x minus 5. What about the right side? Do we have any like terms on the right side? Liam? The 5 and the 10. So that's going to be 15. So we're going to rewrite this, and we can put either the 15 first or second. I'm just going to put my variables first on both of these. So I'm going to do 3x plus 15. All right, all I did was combine the 5 and the 10. Everybody cool with that? Now we've got a problem that's no more complicated than the one that we last did, right? So the steps are exactly the same. I'm going to kind of speed through this one. I'm going to bring my x over here so that my x terms will stay positive. So I'm going to subtract a negative 3x from both sides. I could actually do this in 2 steps if I want to and say I'm also going to add a 5. I know that's mind-blowing, right? You don't have to do it in 2 steps. You can do it, take them, you don't have to do it in 1 step. You can do it in 2 separate steps. But I'm going to go ahead and do it in 1 step. 9 minus 3 is 6x. My 5's cancel out right here. My 3's cancel out right here. And so on this side, I'm just left with 20. So 6x equals 20. Does everybody see how I did that? What's my last step? Divide by 6, right? Divide by 6. And so x equals 20 over 6. This one I can simplify. What am I going to simplify that to? Let me write it on the next line.
10 over 3.
I'm going to simplify it to 10 over 3. Who said that? Is it 1L or 2's?
2.
2. I'm going to go down to verse 2. Look at there. All right. Any questions about that? You guys were amazing. You stood firm in the face of fear and handled the more complicated one. Nice job. All right. Let's do some more complicated distributive properties. So some more complicated distribution problems. All right. If you can do these, you will. The 2 problems, I think it is, distribution problems on the test, are going to be a breeze for you. All right. So let's see. 4xy cubed times x to the 4th y minus 5x. Our rule with distribution doesn't change, even if the problem looks more complicated. What is my rule with distribution? How do I do distribution? Pray really hard and the right answer comes to me. I wouldn't recommend that solution. Not that the Lord couldn't do that, but He expects you to learn the material, right? How would I do it, Cody?
You go on each one and times
Times it by this guy in front here, right? So it's just like we did before. We're distributing through, that's what we're saying. We're taking this term in the front here and we're distributing through and multiplying it by each of the terms that are in the parentheses. Now before I do that, what am I going to look at first?
The variables.
I'm first going to look in the parentheses here to see if any of them have the same variables, which means they're like terms, and I'm going to combine anything that's a like term, right? But in this case here, we've got an x to the 4th times y in the first term, and we've got just an x in the second. So nothing is a like term. There aren't any like terms there. So we just have to multiply everything through by the 4x y cubed. So here's what we're going to do. 4x y cubed times x to the 4th y minus 4x y cubed times 5x. Okay? Yes. Yes, you may. So it's multiplying both of those. So I'm going to rewrite those with our x's, and I'm going to write it in alphabetical order again, just so that we don't miss something, right? Does everybody see that that right there is the same as the problem, as the term above it? I just removed my parentheses, because what does the parentheses mean in that problem? There's no plus or minus in between the parentheses and what's in front of it, so what does it mean?
Multiplication.
It means multiplication. And I can write multiplication just by putting my variables beside one another. That also means multiplication, right? So I'm going to write it like that. I'm going to do the same thing in this one. Minus 4x. I'm going to put my x's together. I'm grabbing my x from here. Actually, what do I need to do first? I missed a step. Since this and this both has a number in it, they both have numbers, I'm going to multiply the numbers, right? So 4 times 5 is 20. Then I'm going to bring the variables in. X times y cubed. Everybody see where I got those variables? And why I have a 20? Does that make sense? So now we're going to combine our variables. What's our rule for combining variables when it's the same base and I'm multiplying them together? What do I do with my exponents?
You put a 1 over them?
I think about this as having a 1 here. So x to the first times x to the fourth. How do I simplify that? I add the exponents, right? That's the same as x to the 1 plus 4. So when I add my exponents here, x to the 1 times x to the fourth is going to be x to the fifth. Right? Another way to think about that is this. Right? I've got 1x times 4 x's. Right? 1x, x to the 1 times 4 x's. So how many x's do I have in all?
5.
I have 5 x's, right? That's really what's going on here. That's why you're adding the exponents together. Okay? So 4x to the fifth, what's my y exponent going to be?
Like 4.
4, right? 3 plus 1 is 4. Good. Minus 20, what's my x exponent going to be?
2.
2. And then we don't have any other y's, so it's just going to stay y cubed. So that will be my final answer for that guy. Okay? If everybody's cool with that, say groovy, Mr. Walker.
Groovy, Mr. Wolf.
Only Liam. Wow, thank you, Liam. Thanks for playing, buddy. All right, you know what, dude, that's worth an extra point today. Nice job. All right, thanks for playing along. So all the rest of you guys are confused, or do you guys want to try it one more time? Groovy, Mr. Walker. That was weak. So weak. All right. We are going to have fun in here, whether you guys like it or not. All right. Let's see. Let's move on to. Now, seriously though, any questions about distribution? You guys think you're good on that? All right. Let's move on to simplifying decimal equations. Now I told you the problem that I skipped in the last chapter was a decimal equation, and they work exactly the same way. But there is something that they didn't talk about in the last lesson that they bring out in this lesson that I think is really important when you're working with decimals. And it just kind of simplifies the problem overall. All right, it just makes it a little easier. Because let's be honest, we think better when it's whole numbers instead of decimals, right? So if I have a problem like this, I can totally use my calculator and do the steps that I've always done, right? Where I say, I'm going to subtract the 0.4, so I'm going to do minus 0.4 because I'm trying to get the m. I'm solving for m, right? Solve for m. And one of my other classes makes fun of the way that I say m. Do you guys think I say m funny?
Yeah.
Do you? How would you say it?
M.
M. Instead of
You
m.
say it like an L.
That's what they say. It sounds like there's an L in there. M. But they don't want me to say, yours sounds more like an I-M. Mine sounds, you said mine sounds like there's an L in it, and they want me to say it where it's M. And I'm like, no, I'm not going to do M. M. All right, so you just kind of stick with my South Georgia way. I'm saying M. All right, so negative 0.4, we're going to subtract that from both sides, 0.4. And we've got calculators, right? So no problem. This cancels out. 4.6 minus 0.4 is going to be 4.2, okay? And then how do I get the m all by itself? Divide by 0.02, right? 0.02 divided by 0.02. Again, we have calculators, and we could punch that in our calculator and get the answer 210, right? But like I said, decimals are harder to work with, and you might accidentally put a decimal in the wrong spot, not put enough zeros there or something like that. So a simpler way to do this problem, I think, is before you do anything, get rid of the decimals. How am I going to get rid of my decimals?
Move the decimal point.
Move the decimal point, okay, but can I just move the decimal point?
You can divide.
I can divide. Actually, if I want to move that, since these numbers are smaller, Well, actually, this would be true even if the number was bigger than 1. If I want to get rid of my decimal, I want to move my decimal to the right. You guys see that? And in order to move my decimal to the right, I want to multiply it by some multiple of 10. Right? Because does everybody know that rule that every time you take a decimal and you multiply it times 10, it moves the decimal place one place to the right. So if I multiply 4.23 times 10, then that becomes 42.3. If I multiply 4.23 times 100, that's going to move it 2 places to the right, so I get 423. If I multiply 4.23 times 1,000, that's going to move it 3 places to the right, and I get 4230. You guys seen that trick before? So however many zeros you have after the 1, you move your decimal that many places to the right. So 1 0, move it 1 place. 2 zeros, move it 2 places to the right. 3 zeros, I move it 1, 2, and I have another 0 there that I jump past. All right, so that's how I get rid of the decimals. So algebra says whatever I do to one side of the equation, I can do that as long as I do the same thing to the other side of the equation, right? I put too many zeros in here. I told you decimals were confusing. There we go. I'm going to multiply this times 100. Why am I multiplying it times 100? Why didn't I just multiply it times 10?
Because you needed it to move over 2 decimal points.
I got to get rid of this one here that's got 2 decimal points, right? So if I multiply this times 100, this and that means all of these terms I'm going to move the decimal place 2 places to the right. So that becomes 4 and then 40. So this is 40 plus this becomes just 2 when I move it 2 places to the right. 2m, m, and then 4.6 times 100 is going to be moving my decimal place 2 places to the right. There's an understood 0 here, 460. Okay? Make sense to everybody? Yes? Groovy, Mr. Walker. Thank you. You got it. See, Ada did it too. All right, she's just racking up. You guys are racking up the points. What am I doing now? Now this is a lot simpler looking, right? So I subtract the 40 from both sides to get 2m. M equals 420. I'm so self-conscious of it now. It's ridiculous. And then what I do, Allison, since you know how to say M correctly, what would I do now?
You divide both sides by 2.
Divide both sides by 2, exactly. 2, 2. See, this we can all do in our head. 420 is easy to divide by 2. I get 210. Notice I got the same exact answer that I got over here, but I didn't need a calculator for it, right? And I didn't run the risk of putting too many zeros or a decimal somewhere it wasn't supposed to be. So that's just a way to simplify problems that have decimals in it. You multiply by some multiple of 10 to get rid of the decimals, okay? All right. Oh, wow. Last section. First thing, fractional parts of numbers. So if I say 1/4 of 40, what does that equal?
10.
It equals 10, right? If you divide 40 into 4 parts, you would have 10 in those 4 parts, right? If we had 40 cookies and we each got 1/4 of those cookies, we each get 10 cookies, right? So 1/4 of 40 is 10. Well, this basic equation here is what fractional parts of numbers looks like. And what you actually do is when you say 1/4 of 40, what we really did was we took 1/4 and we multiplied it with the 40, right? 1/4 times 40. If you punch that in your calculator, your 1/4 would get converted to 0.25, and 0.25 times 40 would be 10, right? We can think of it as when we multiply fractions, we think of this 40 as being over an understood 1, and so we get 40 over 4, and when we divide 40 by 4, we get 10, right? So fractional parts is just some fraction multiplied by some whole part, and that gives you the fractional part. All right, so you could write it like this, some fraction times the of portion, some fraction of some number equals or is, whatever the other number is. So that's kind of how they write that in the book. I've seen it written something more like this: f times the whole equals the part, right? Something like that. That's kind of how I've seen it written with fractions and percentages and decimals. You've got some portion of a whole number, and you end up with a part, right? So this is the whole, and this is the part. So this first section here is just about being able to do that. And so if they said 3/4 with these, they're simple word problems, but with these simple word problems, when you see the word of in these word problems, we're talking about this portion. When you see is, the is equates with the equals, and we're talking about this portion. All right? So this problem says 3/4 of what number is 69? And so if we were to write this with variables, we would say 3/4 times some number w equals 69. All right? And this is a simple equation that we then should know how to solve. 3/4 times w, w is just a variable, so I could just write that as 3/4 w equals 69. How do I solve for the w? How did we do that in the last section?
Division.
Huh?
Division.
We do division, but when we divide by a fraction, that's the same as doing what? Multiplying by the reciprocal, right? So we're going to say multiply both sides by 3/4. I'm sorry, not 3/4, my bad. We said the reciprocal, 4/3. Those all cancel out. I'm left with w there. And so 69 times 4/3, I think 3 will go into 69. 3 times 20 is 60, and so 23. So this would be 23 actually, times 4. So this will go into this 23 times. 23 times 4, I don't know, that's 100 minus 12, so 88. Is that right? No, that's not right. What?
Pretty sure it's
92? It's got to end in a 2. 4 times 3 is 12. Yeah, 92. You're right. What did I do wrong there? Oh, it's 2. 2 times 4 is 8. So 100 minus 8. All right, so 92. You guys see how we did that? You just build in an equation, just like all the equations that we've done before. So you build the equation correctly, and then you solve for the missing variable. All right? That's all you have to do on these. Any questions about that? Last example. All right? I know we're right at that time, so I'm going to do this very, very quickly. It's a really simple concept. We've done this before. X squared plus 2x. Find the value of that if x equals 2. How do I do that?
You plug in all the x's with 2.
I put a 2 in for all of my x's, so I say 2 squared plus 2 times 2, right? And I say that equals 4 plus 4, or 8, okay? When we have something like this, we call this a function. If we say y equals that, like if you had a graphing calculator, you could plug this in, y equals that value there, and it would graph that function for you. But another way to write that is f of x equals x squared plus 2x. That's what we call functional notation. So we're writing this thing here as a function that we call f of x. If I want you to plug in 2 for this function, what I would say is I want you to find f of 2. All right? So notice what I did here. I replaced the x with a 2. Okay? So since I replaced the x with a 2, that means to find the value of this, I need to put a 2 in here for each of these guys. and solve it, okay? If I had said f of 3, same thing, but it's with a 3 in there for the x. Okay, does that make sense to everybody? So I'm going to give you some homework problems. We can review that again at the beginning of class next week, but I'm going to give you some homework problems that let you practice this functional notation, okay? All right, so we got three lessons, 25 through 28, and so you'll be doing the practice sets and the problem sets odd for those guys, all right? You guys have an excellent week. See ya. Sorry I kept you a couple minutes over.